Good evening, everybody, and thank you for the opportunity to come and talk to you about one of the things that I have loved about my job and all the things that I've been doing in the last 5 or 6 years. Fallon and I met getting on for a year ago, I guess, just as Dartech was kicking off, and we had a hackathon, and I think that was kind of what triggered an interest in this. I'm hoping that we can talk to you about why flow-based programming, which is really what I want to talk about here, is so productive, why it's so much fun, and where this low-code aspect kicks in, low-code and no-code. So I've got a couple of slides, let's say half a dozen slides. I want to do a bit of positioning on what the idea of Node-RED and flow-based programming and its context around low code and no code is about. I want to give you some samples, and particularly since Fan kind of gave that introduction about the idea of using computing to make the world better for everyone. There's some great examples of where Node-RED's been used. As we go along, I can't see the chat window because I've got this full screen slide or I'll be demoing or something. So if you've got questions, put them in the chat and we'll get them towards the end. And Fan, if there's anything that comes up that obviously would be better answered as we go, please just interrupt me and we'll get going. I'm positioning myself here. I am an IBM developer, but I'm talking to you tonight as just me, Ross Cruikshank. I'm a developer advocate, which means I love talking to developers, helping people build software, try stuff out, and then if it's relevant to what I do in my job, then I'll take that back into IBM, where I work, to say, can we get this changed in the product so that it's easier to use or better or more accessible? But my role in life is really to try and help people try out software. Mostly at the moment I'm working on IBM Z, but in the past I've worked on cloud, I've worked on PCs, Raspberry Pis, Arduinos, so the whole range of computing platforms, microcontrollers and everything else. So some of the things I'll show you tonight go across that entire range. But hopefully it's interesting. I'm going to kind of work this through almost like a meetup. So I'll show you kind of a little bit of background of where I came from and why this Node-RED appealed to me so much when I first saw it. I started work in the 80s, mid 80s. Let's be kind, mid 80s, to join a chip design group in IBM down at the Hursley Lab in Winchester, and that's the kind of technology I was using. It was what I call a 3277 green screen mainframe terminal, and attached to it was this graphics adapter attached bimodal storage display unit, which meant it was basically a phosphorescing green screen where you could do diagrams and it would kind of stay on. The screen would glow much longer than a TV might, so it could draw out diagrams for you. And we had a light pen, and we could draw diagrams, and we would do circuit design, so discrete circuits. We could do logic design. So depending on which library you were using, you could pick chip design components, basic blocks, or you could pick discrete components, so 74LS componentry, or you could pick just resistors, capacitors, diodes, whatever you needed. Or you could work at the logic level and just say what you wanted your logic to be. And then in the background, the tool would compile those logical gates into components that could actually be placed on either in a chip, because you had a library of larger parts like shift register or a buffer set, or pick a 74LS type product which could do something similar. So it would condense the amount of logic into something that was already there, already usable. And then we would submit that to chip design and then wait probably for 18 months for the project to be cancelled, because That's how long it took to get products through. We'd get cancelled, we get another project. And I moved rapidly from there into software development because I wanted to be able to do things that took maybe a day to work rather than 18 months before you got to see it to work. So I went off and did other things in the world of software and consulting and so on. And when I came back to IBM about 10, 12 years ago, I was working in software group, and I came across an old buddy of mine, David Conway-Jones, who was working in emerging technologies and working with IoT devices. And we started talking about how we could link up IoT, get microcontrollers and sensors, and at the time IBM had a business called Sensors and Actuators. So we actually built sensors, controllers, and did integration work for services business. And that's now gone. But the emerging technologies had been trying to figure out ways to make it easy for people to build the data flows that came from serial devices that were either being pulled or were transmitting at relatively regular frequencies, and make that into data that could then be handled by regular programs. And around about the same sort of time, they had been working on with a technology called MQTT, which was the early open protocol for doing message queuing for telemetry devices, which was basically sensors and actuators, encapsulating that data, being able to transmit it over very poor bandwidth networks, small packets of data that could be used as sensor observations or as events, depending on how gross the data content was and how frequently you transmitted it. And at some point, Dave Conway-Jones showed me this tool that he was using called Node-RED. And Node-RED was just visual programming that looked just like, I went the wrong way, just like these flows, where you had events coming in from the left-hand side, some blocks to do something with the data, and then passing it on to the next block or on to the next major component to do additional work or producing some kind of output. Oh, I know what this is. This would be fantastic if we could do that with software. So since then, I've been using it for all kinds of things, not really related to IoT, but you will see Node-RED mentioned usually in context of IoT, mainly because it uses Node.js under the covers for its event processing. So it's very lightweight on CPU because it just sits there waiting for an interrupt to say, here's something for you to do now that the data's arrived. It's great if you take that and use it in the context of using web-based APIs, which is lots of time waiting for things to come back. You're just hanging around, synchronized, waiting for an event to happen, or maybe you're providing a webhook so that eventually data come back to you. There's a lot of time sitting around, so you can be doing lots of other instances of the same data, same types of data flow. So Node-RED gives us that. It's fantastic for rapid prototyping because all the kind of main bits of the code that you would want to use are analogous in my mind to these components that you already had on the shelf. You just put them together in different ways. So it's very much a reuse model. It's great for doing a minimum viable product because you can get a user interface up and running, you can get data flows going, you can get in and out of databases, services, APIs with, I'll show you in a second, very little code. You're configuring more often than not rather than actually putting any code in. There is the scope to do code, which is one of the things I want to cover in a second. But it gives you this kind of general programming capability. Before I forget, and this will come back in the recording, here's my contact information. Some non-IBM stuff and then some IBM stuff and some links. Well, that's gone gray, but you'll get the version that doesn't obscure the links in here. Lots of stuff around Node-RED. You can come back to that later, but essentially this is developer resources, background information, and some of it I'll cover in a minute. So now I'm going to switch over to demo mode. So if the demo gods are kind, I'll switch over to a huge array of tabs, which I'm going to go through at varying speeds depending on what they are, but mostly what I'm going to get to down here is a demo. First, really, some resources that might be handy. Low code is becoming popular in terms of what you can do, the ability to enable people who are not necessarily programmers to build logical constructs. I'm going to say programs, but they're constructs which apply to generally domain-specific uses. So Mendix has this kind of evaluation criteria. How would you know? Is it easy for people to use? Do you have to have special skills? Do you need to understand logic? All of those are somewhat useful, but what you end up with is a drift into what now is prevalent in the kind of robotic process automation world or the data science world. So I've got a couple of examples here. If you're in any way academic, you might probably have heard of SPSS in probably the old view of how things worked. In recent years, it's been given a graphical tool to build data flows and data manipulations for analysis. IBM acquired it, but it's still available in its old forms, I think, at universities under different licensing models. But you'll see you've got data flows, you've got a panel on the left-hand side that says, what are the various transforms and operations you can use. You can drag them onto the palette. So you can pick up filters, we can get data restructuring, we can do some modeling here for trees, random trees, forests. We can bring in linear regressions, right? And generally the model for these tools is you pick one across, drag it onto the canvas, we'll click on it to open it up and configure it. What you find though is that these tools are generally built for a limited domain. So it relies on you knowing what all these things are in the context of the tool. And it doesn't have a lot of scope for using it for anything else other than what it was designed. There are a couple of other examples that come up over the years, things like process modeling tools, BPMN, BP, and yeah, notation generators for business process execution environments. So you might have a business process engine, you define your processes. We have a tool here called BlueWorks Live, which is a live swim lane based modeling tool for doing process design and engineering. And it's timed out while I was having my tea. But you'll see it's a low code tool. It's got a paradigm that is related to process design, process flows. So you can choose how you want to do it. You can have it as maps, you can have it as swim lanes, you can just have milestones, and then you link the various processes together. So you can add metrics about what you're doing in your process. But again, it still stays in this kind of meta level of linking together what it is that is going to happen, but not necessarily the implementation of it. And it is very much still a domain-oriented tool. So when I saw Node-RED, I thought, oh, this is a broader thing. Robotic process automation is using low code. There's lots of stuff in here if you're interested about low code, but you'll see it comes up again and again with things like BPMN, so business process management, robotic process automation. In some cases, so things like engineering processes, there's been a long history of tools like Wonderware. Can't remember what it's called now, but Wonderware was a fantastic visual programming tool, where you had your palettes, you dragged in your components for your process, linked them together, stuck on your instrumentation, and you had both a live dashboard display of what the process was doing and the ability to control it. And that's been around since 80s, 90s. but we're kind of narrowing the scope with some of these tools. I had a look at the Gartner, as mentioned here in the Gartner Quadrant, Magic Quadrant, about low code versus no code. And the no code tools are really quite a narrow area, very much about a particular strand of business process that you can model within with no code. And low code is that we can nearly do it, but we would need to expand a little bit so we can put some programming in when we want to call things out. But I looked at the Gartner Quadrant, and its focus is very much on commercial products. It doesn't necessarily address what's the technology that's available. It talks about what products are available. And again, most of where they're playing is in the market of robotic process automation, forms management, sales flows, and very little here that is a kind of general purpose flow-based programming tool. So you'll see here, if you look on Wikipedia, which of course is the source of all truth, you look at the kinds of examples of tools that you can find, and the paradigms that are used for building these tools. Yeah, so there's all about end user computing, which is giving people the ability to create consumable computing without necessarily having programming background. So key pieces here is you have to think logically within the domain that you're trying to do some problem solving. And the thing that comes out of this for me is the flow-based programming. And that's kind of where I'm going to kind of jump out and go back to, so where are we? So flow-based programming is implemented by Node-RED. Let's see here with the components that are used in it. It's home here. The reason I wanted to go to this page is here are Dave Conway-Jones, who I spent a couple of years working in our hardware design group 30 something years ago. He's still with IBM, I'm still with IBM. But along with him, he met Nick O'Leary, and they are the guys that looked at using the flow-based programming model to build Node-RED. So without spending too much more time, I'll give you an idea of how this is used and also how to do it. So when I first got back to working in the Hersley lab a few years ago, one of the people I worked with in the past around MQTT was Andy Stanford Clark, who lives on the Isle of Wight. And he was the CTO for IBM for a while, but he's a master inventor. There's lots of stuff on the Isle of Wight around technology introduction, things like electric vehicles and power management systems, domestic power optimization. But he also works with Black Gang Chine Dinosaur Park, and you can go there, and there's been a theme park there for quite a long time. It's a staple of visiting the Isle of Wight. They had at the time, some time back now, a desire to kind of beef up the story of the dinosaurs, having, I think, seen Jurassic Park. I thought, I wish we could do a little bit more than that, just having effectively nodding creatures that could make roars and make it much more interactive. So as people move through the park, could they make the dinosaurs' behavior change based on who was coming, what kind of groups they could put together, and changing the sounds that they made and the motions they made to make it much more, not like an animatronic play, but much more responsive environment for families to enjoy. So one of the things that was done in the very early days was of both Raspberry Pi and Node-RED, was to put them together and say, you've got a prototyping tool, which is fantastic as the Raspberry Pi. You've got simple I/O, and you need a way to interface that with these giant dinosaurs. What could you use that would be a safe tool to interact with the data flows coming in and out of a GPIO bus without falling over if you got the data wrong, if you mishandled it, without falling over if the data came in too fast or too slow. How could you use that environment and then give it out to a team of enthusiasts and say, what can we do? Let's have a hack. And it was they did this jam model under the sponsorship of Dr. Lucy Rogers, who you'll find still a big fan of MQTT and Node-RED. Lucy Rogers was part of that event to encourage people to try stuff out. So it was a kind of open hack jam where they played around with some very simple microcontrollers, linked them up to a virtual model of the dinosaurs. So really simple, just with lights and a bit of cardboard, to make sure that when they wanted to effect a change on the real dinosaur, a light would come on that would indicate that an actuator had fired or that a soundtrack clip was going to play. Once they got it all to work in the real world, they then attached that to the controller devices that had been mapped onto the bus through a GPIO adapter, and up fired these dinosaurs. And that's been now going for 5 or 6 years, where there's a regular thing in December every year where people come along with Node-RED, Raspberry Pis, and then try to improve the environment at Black Gang Chine. And it's kind of spurred on people to think, well, what else could we do? What could be more useful? And one of the people that got interested in it was Marwell Zoo, which is just outside Winchester. And they did a project, you can find more details on it here, but they did a project with us around using Node-RED to capture the images of the Nyala deers that were coming in and out of their stall, for want of a better word, at night. These deer would come in, lie around in the straw, get up during the night, walk outside, wander around and graze and come back in again. And then in the winter, they do that all through the day. And the zoo was really interested in how to safely optimize their power so that they could be more sustainable, less wasteful, but make sure that they were always providing the right level of heating based on the presence or absence of deer. So Node-RED was used to prototype that using image classification and some really simple AI. And that led us through to a solution now that's being looked at by other zoos. But using this open source technology for Node-RED, image capture, and then driving and controlling the heating elements and some of the airflow devices. So real simple stuff. And then last one of sample is we've been actually integrating in the Call for Code, which is an international kind of open source group that IBM is a part of. So it's a kind of save the world initiatives in lots of different ways: hunger, water preservation and sustainability, energy conservation. We do stuff with human rights, and it's all designed to be open source. Working with the Dave Clark cause, which is about fundraising for and doing these kind of humanitarian things. And you find in there, we've got starter kits for how to use Node-RED to build monitors for incorporating predictive flows, bringing in weather data, all kinds of stuff that can be used to help in lots of humanitarian projects. So if you're interested in the kind of technical background to this, there's a great article that Paul Morrison did. You can find the links here from flow-based programming. There's a guy called Paul Morrison who worked for IBM, published a paper back in 1971, which was about data responsive modular interleaved task programming system, which clearly tells you that this is about flow-based programming. It's really short paper, but it's about how to model systems, because he built simulation systems with IBM, how to model and simulate systems, and then realized that if you could simulate these systems with what we now call things like mocking, where you create fake versions of real things, you could build a data flow service that could actually model what would happen in the real world, and then it effectively produce the necessary output at the end to create the effect that you want. So good paper there. Paul is still around. So although he started in the 70s, he's still there, still an active member of the IT community. And you'll see in here, we've got members of things like mentions of Node-RED in his papers about systems. You mentioned something here about them being synchronous and procedural in nature. And actually what happened, because Node-RED has moved on and is now part of the Node community, although it runs synchronously, the function is actually all asynchronous. So some of the benefits of Node have made it a much more functional environment. But all the background here would suggest that Node-RED is one of these flow-based programming inspired systems. There are some things that it doesn't do, but that doesn't make it any less usable as a programming tool. So, Node-RED, you'll see, started off by Nick. He was kind of the project lead, working with Dave CJ. Back in 2013, he did the first publication for the visual tool for wiring the Internet of Things, because that's really where it started. And a couple of years ago, it got then adopted by what was then now the OpenJS Foundation. So it's an OpenJS project, and has gone far beyond IoT, and is now a fantastic tool for building pretty much anything you want. And it runs on just about any platform that you can install Node.js onto. There's a great presentation by Dave Conway-Jones, which I'll show you the first kind of flow views of these. These started out as the Node-RED flows back in the day, and it's very little has changed in the look and feel. It's just the capabilities have grown. And you see Dave's sample here was to use some WebSockets to drive an interface to a Roomba device. So programming a carpet sweeping device, picking up monitoring information from the window sensors and using it to move the bot around within the house. So a home automation. And lots of Node-RED projects start off with people being really enthusiastic for home automation. So you find a lot of detail here about what the philosophy was around Node-RED. It's not meant to be at that time an enterprise strength application runtime. It was meant to be a kind of prototyping tool where you could try stuff out on a small device, and then you'd figure out what you would use to build your actual program, your real program, if you like. But over the nearly 10 years that it's been running now, let's call it 9 since it went public, I've run these systems in production for years at a time with virtually no downtime. We're running, Joris, who's on the call tonight, we both work on a system where we're trying to get more people with skills on the IBM Z platform, and we run a Node-RED instance that manages all the flows between us and our third party for setting challenges and doing scoring and so on. And it runs in the cloud, managing all these data flows like some giant if this then that type service, but on steroids. So what's changed in those years is definitely is application strength capability. You can use it as a dashboard with widgets. You can use it for mobile application builders. It's moved on quite a bit since then. You could get all the information you need on Node-RED from the Node-RED site. It is now version 2. It's taken off rapidly since Nick O'Leary left IBM and has now started his own company called FlowForge, which I'll show you the links for later. There's all the documentation to get going, how to get started, user guides, tutorials, And the key part here is all of this is now open source, which means you can find information about all the different flows, samples, examples, and create your own code and contribute to the community. So you'll see here these nodes, 3,754 tonight. Those are nodes that have been contributed by the community, where someone has come up with some logic to talk to a device or to a service, to wrap around some kind of capability that we want to make easy for people to program to. They've created the adapter nodes and published them as open source. And that makes it a never-ending community, if you like. And there are branches throughout the world now. There's evangelists in Japan that are doing all the Japanese conversion, but they're also doing a whole lot of process engineering work in it as part of their production route. I mentioned it was OpenJS. I should probably have that further back there, but next time. So starter applications, IBM developer, which is a free site. You get lots of stuff from Nick from when he was with IBM, and also a friend of mine, John Wallachy, has done a lot of work around the call for code on using Node-RED. So let's have a look. So here's some real stuff finally, for those of you that have thought, oh, when's he going to show us the stuff? So first thing I want to show you is an actual real Raspberry Pi. There we go. Where's the camera? Yeah, this is a Raspberry Pi with a little device that is, I think, from Adafruit. Yeah, it's an Adafruit breakout board with a little color matrix on it, which we can control by me just clicking on the buttons inside this program. So I can clear it. I can send dots to it, make the lights come on in different ways. You'll see, hopefully, these little lights popping up, yellows and reds, going off and on. I can send a mess of colors, which you can, trust me, that's just flaring, but there's lots of different colors in there. All of that is inside the Node-RED environment. And the thing that makes that all work is this little node where we configure it with the information that we want to send to our device. Do we want to send, where's the message coming from? Do we want to, just let them back in. Do we want to, this is working off of the I2C bus. So there's the address that it talks to, the commands we're doing, what colors we want to send, and so on. So nobody needs to program anything here. You just send the thing you want to happen. I want to send this color to that spot on the device. Make it happen for me, please. So I want to clear it, turns it all off. I want to send a green dot. And of course, my background green screen is green, so that's not going to show up very well. Let's send a red dot instead. Clear that. So a little red dot. Okay, so I can use my Raspberry Pi. I could have done this with an Arduino as well. There are Arduino modules for talking directly to this. So really simple to do. That's much like the original scope of where Node-RED started, of being able to drag these things from the palette, just like in the SPSS modeler or workflow tools. What's in the palette that you can use? There's networking, there's some simple programming constructs, which I'll show you in a sec. Some common operations which have grown out of the fact that we're talking to JSON APIs or CSV files, XML, that have grown over the years when people just kept doing the same thing over and over again until they said, really, we could just do the node for this. So we created it. And so Raspberry Pi, I think it's probably the smallest device I've got that it works on, although you can run Node-RED on an Android phone. You can install Node.js on it. You can run it on there. The Intel Atoms had it for a while. And I'm going to stop playing with that one because it's sharp, sticking into my fingers. So one end of the spectrum, on a Raspberry Pi, you can run it on iPads. No, you can't. You can run it on Android-based pads. You can build little interfaces for it. So this one's just using the this little template here for a web page. So you've got the ability to create really simple, minimal interfaces, just enough to drive the interface. And what this does is just allow me to bring in the commands, format them into a matrix command to send to the matrix device, and then send it off. So pick the colors from the color picker on the web page. Just use some web components to do that, and then submit. And my little device, you can't see the colors, but my little device now has this little yellow dot appear on here. So really simple. To right at the other end of the thing, where this is where Joris and I are currently working, we have APIs that are integrations with our third party that looks after all our memberships and challenges and so on. They send us information as we get various events happen in the system, and I can make flows really simply to integrate with object storage. We publish documents, so we can get information in and out of our object store, just passing PDFs or PowerPoints information, creating the stores, which can then be consumed by our third party. We have, we can mock stuff up while we're trying things out. We can create a little webhook, just capture the data so we can see it work. And I'll show you that in a second. So this is the live version. It's in production now and very much a production grade environment. I've got some stuff we're doing. We're doing a hackathon in a couple of weeks' time in the US at Share, which is a mainframe oriented exhibition and show and education site, where we'll be doing stuff with a little device simulator. And this is show you what this looks like. We have web endpoint. We have some style sheets just because we want to do some styles. So that's just regular CSS. We have a web page with some JavaScript, some HTML, and a WebSocket. And when this runs, if I can get a copy of that, so it'll be the first live thing we're going to try and do here. Stick it on the end. And we'll go to our device. So this lets us simulate devices instead of having to give everybody a device. We'll put in a little interface, set my publishing interval, mess around with the sensors, little sensor emulators, and publish. And that's generating messages which are going to get published back to my application. Get back to it here. And we'll see down here, I'm getting events coming in that have these IoT events where I publish the data from the simulator out to the cloud, and then they appear back in here through our device subscriptions. So I can post data out, get the data back, feed it back through to the view with WebSockets so that it can appear on the simulator if we want, but I can use it to drive real world things on a mainframe if I want. And that's really where I'm going to take you to next is mainframe. This stuff is, I'm going to just use the type code sample endpoint because it's really handy for doing APIs. So for the next 15 minutes, let's just demo and you'll see it in action. Type code, if I click on one of these, you get some JSON. It's just JSON in arrays and individual items. And what I'm going to show you is there's a server that's not running. So I'm just going to start it so you can see it fire up. If I get back to here, I'll connect to the server that's going to host this. And I can do red. And you'll see it coming up. It's running Node.js 16, which is the current version. It's running on a mainframe. It's running on an IBM Z system running Linux. This is Red Hat Linux, which is the same as the Red Hat Linux you run on a laptop or pretty much anything. It's just Linux. We're running on port 1880, which is the default port. very close to 1883, which is the MQTT port. And if I switch on to the system and I refresh, we should have a live connection. So this is the live application environment. You can turn this off, so you can turn off the editor once you've got an application world, but by default, it comes with the editor built in, which means you can run it anywhere you can get a browser to work. So I can use the browser to talk to my Raspberry Pi. So that view here, that's talking to my Raspberry Pi on my home network. Weevil.local. It's running off a browser on my MacBook, but I can also run it on the Pi with a browser. Here, Mainframe's not too clever on browsers, but they can do IP. So I can go to my palette here on my Mainframe. I've got things that I'm going to drag from my palette. Fan mentioned the Hello World program. Here we go. We open it up, put some configuration in. I'm going to put a string in that says hello world. Done. Big red button up on the top right here says it's ready to go. I deploy, and here's my hello world. So the only thing I had to do was type hello world really to make that work. So I'm assuming you agree there was no code involved in that. Underneath, huge amounts of code that's reusable and everything else. So the one thing I want to make clear, Node-RED is not a code generator. There's no code being generated under the covers here, being compiled and reinstantiated and reloaded. What it's doing is creating a configuration flow that is very like my old chip design data sets, which said, here's a block, here's a net that goes from that block to the next block, and this is the data that flows over that net. And it's just blocks and nets stored as a big JSON file. And those blocks are modules that are part of an NPM package. If we wanted to make this Hello World program, such as it is, into something that you could use not in the editor, so like in the real world, what we would do is say, well, let's take that and we'll put it in here, and we'll say, let's make this into something a little bit more sophisticated. I can drop that on. And now when I publish it, you can see now it says this is the payload Hello World, because it's got mustache templating, which is common rendering support tool for Node.js and web pages. Node-RED is an Express Node.js application. So it has the Express engine built into it, which means we can create websites by just doing things like this. I will put in an endpoint here for BCS Red and a response. Pop that back out. So you've got a get coming in, you need to have a response, otherwise whoever calls you is just going to wait forever. And deploy that. Now we have a web page. So if I now take that BCS bed and we'll go to this site, place that one because we're not doing that one anymore. We'll go to BCS bed. Okay, so we get rubbish, but it works nearly. So this is where the prototyping aspect comes in. Our function here says we want to get payload, which is from the message payload object, but clearly it's not set by anything that we know about. So what does the BCS bed payload look like when it arrives from the web? So what we can do here is we can add a node in, and we create a separate flow which says whatever else you do with this data, let me see it in my debug node. And I can deploy again and live. So nothing changes here because we didn't change what the flow was doing. We are now getting some information in the debug about what's in the payload. Payload is an object that's empty. That's good. But we also get all this information about where is it coming from, what's coming in the request, because that's all been abstracted and packaged for us. You can see we've got some parsed URL information. We've got header information that'll tell us where did this come from. We might even get a user agent string. Here we go. There's our user agent string. It's telling us which browser it's come from. You can get your requesting IP address, those kind of things. So we can take one of those properties and say, instead of payload, let's have the, where are we? Let's make it more useful. Yeah, let's go for, let's take bold headers. So we look for all of the rec, all the request objects. And we're going to, for all of those, so we'll hash and slash our way through the request objects, we'll get all the headers. We'll go through the raw headers. Is this programming? I don't think so. I think this is just templating. We're looking at our data that we had never seen before. And we can just tack some stuff on here, and we're going to look for the values. So let's, we don't know what they're called. They're just unnamed array elements. Because I know that this is going to come out in a great big long string, otherwise I'll put in a break because it's HTML. Now when I render it, I get all the information that was in the header that I can use straight away. Really no programming, just some templating to generate HTML on the fly. So we can move these around, make it nice and tidy. Now we've got it to work. Well, let's think, okay, so we don't want it to just do that. Maybe there's more to it. We want to be able to pass some parameters to it. So if I pass a parameter and say, nothing's going to change in this, but inside the application, I'm find here's my new got payload, and that's been abstracted for me. So now I can say, oh, if there's if there are queries with variables in them, those variables will appear in the payload. So I can access those by name, and I can stick them down at the end. And let's say I want to create a div. It's a relatively simple style equals, say, color. Put in my name. Apply that. Clear out all the rubbish from there. And now when I do this, I should get my name at the bottom, but I don't, because nothing really broke, right? But I need to say this is payload. Oh, no. So nothing broke, it didn't fall over. I was able to go in, quickly make it change, and then here's my name appeared down the bottom. So really quick to build stuff. You can use highlighting if you want to create the things. I'm just showing you a little div, but you can use all the CSS you need to make it work. All that stuff with the device. My device. Oh, no, wrong one. My device. All the styling in here. The sliders and the output models and stuff, the colors, that's all done just with that really simple style sheet. So the other aspect here is it's a type code. So this is for accessing data anywhere we want. If we wanted to pull it from a database, yeah, so we've got no databases. Maybe what we need to do is get hold of, go to manage palette. Then we can look at those 3,754 nodes. Maybe say one of them is a Redis database. Yes, it is. So now we can install Redis. This doesn't install Redis, it installs the ability for me to access Redis. And I can look at it and say, ooh, is that really useful for me? Could I use this? I can bring it up. It's going to talk to, by default, to a local host of here. Not really useful because this is basically outputting information. You'll see the output here. It says in the documentation tab, it says it's for output. So that's not really for getting stuff from databases. So you can always go back to the palette and say, let's not do that. Let's look for a different one. This, and we'll see here's one that does publish and subscribe. There's one that does listing. You can also do some Lua scripting if you really want to. So this might be a better one. So we can install that too. See which one works for us. This one has an in and an out and a configure commands, much better. That gives us a lot more flexibility. Let's see here, that's the kind of thing that we're looking for. Does it give us the ability to do gets and sets? Yes, it does. We can do get, set. There we are. So we can get and set key-based operations in our Redis server. So we can have a really fast in-memory cache service if we want. So you can do that for pretty much anything. If you look out of those 3,700 nodes, there's bound to be something that you might find useful. You'll also find MySQL, SQLite, PostgreSQL, DB2, Oracle. They're all there. MySQL Server for Microsoft. You'll also find nodes for talking to, let's see, where are we? AWS, for example. If you wanted to have a look at talking to AWS, here's all the tools for talking to AWS. So you can talk to an Amazon's an S3 bucket. You can talk to the database services, DynamoDB. You can talk to their IoT service. So Node-RED gives you the ability to link across different platforms as well. You can run it in the cloud. And one of the cool things I just wanted to do really quickly, Mainframe Z Linux, not known for being an IoT device, but just quickly, I can fire up a new broker here with no code. I want to go to the MQTT Cheerlight service. So this is a service that you can subscribe to, which will anybody can publish to, and it will send you the colors that are currently being published. Cheerlights. This started out as a kind of Christmas tree project. So you can run your Christmas tree lights being controlled by the world. So, debug message here. We'll deploy there. Look in debug and clear this out. Every 20 or 30 seconds or so, somebody will publish a new event on Cheerlights, which will have a color to it. And you can use that color to create a chaser light that you have no control over, just random lights. It was used for kind of mall Christmas trees where people around the world would choose the colors. But you've got built-in IoT capabilities here. You can pick public. This was a public MQTT server. You can use your own IoT service if you've got one to control events. And usually, if I redeploy, it picks up an event straight away. There we go. So we've got picked up yellow. If you don't like yellow, you can put one in and say, how about you give me the RGB version? And this will do the same. We can put it to the same debug nodes. We can create our own debug nodes. We can turn off debug nodes once we know that they're good. We've got the operation right. We don't need to see those flows anymore. And now when we deploy, we get both the yellow and the RGB hex equivalent. So that lets us control things from the outside world inside this program. And then if we want to go and make some stuff happen in other parts of the world, we can go to our API. Let's see, you mentioned type your code, so rather than forget to do it, let's go to type your code. take that here, just one of those posts, drag it into the application, put the URL there. No, we don't. That's the wrong one. Type of code, go to posts. This is my keyboard problem. Go. Put it in there. Now, hopefully you won't be too surprised that what will come out from this is going to be the same JSON data that we just saw on the web page. So if I trigger that, here's my data. It's come through as text though. And there's a couple of ways we can tackle that, but this happens often enough where you think, I really need it as JSON. So it looks like JSON. Maybe there's a node down here. Oh, look, there's one. I can just pop my JSON node on there, redeploy, and clear out the bin. And now what I get back is all of my data now rendered as JSON for me. You will get errors if it's not JSON. You'll get an error which you can catch, and there's a catch node for handling things where it doesn't go quite the way you were expecting because maybe the data's changed, your API's changed version, and so on. So to me, it's a great tool for exploring an API that you've never seen. You can see what the data looks like. You can now figure out whether you can use it in any way. If I wanted to create, say, a web page now where that data is actually what I want to put onto my web page, I'll show you what it looks like. First of all, I'll turn that one off. So now we go back to our BCS beds page. BCS bed. Now we've got all that text because it's not being rendered. I haven't done anything to make it into a web page, but I've already showed you how to do the templating. So we can just stick a template on. We know what the object properties are. We can now easily turn that into a table without trying too hard. Table. We can create a row for everyone that comes in. And just say, all right, for every item that's coming in the payload, and slash our way through that. Here's our payload. We want to create a row. I know this is not the way to do tables in this modern age, but we can, let's say we wanted to create something quick and dirty to get going. We'll create a little row item here, and what we'll do is have I think it is actually the type code. Ref equals, we'll take the type code information for a post, and I think if we do post, if we put one, we can get just an individual one, so we can drill down. So we can now make href. It's going to be the type of code post information. That in there, and we'll say it's the ID property because we know what that is. We can put our title in here. Title in. And here. There, it's the end of the A href, at the end of our post. something not right there. We'll catch that in a second. And here we've got a new cell for the table. And I need the end of that one. And now our magical review should give us a whole load of table items and a link which will take us to the more detailed base, which we can also then retrieve and then modify as we want. So we can get data in and out of the real world, modify it for our little purpose, and then carry on. So look, an enormous if this then that, but no coding. If you really want to do code, there are modules in here. There's a thing called the function node. The function node will let you write actual raw JavaScript. But most of the time, what you can do is say things in here with your switch node. And a switch node lets you test and create a variety of different tests. Look for regular expressions. You can look for values. Are the properties there? Or is it null values? Or you can do some expression checks. And the other one could be, if it's none of those, do something else. And when you do those kind of tests, you end up with different nodes, which can then branch out to give you broader use of the tools. And make decisions based on just what's happening in the particular flows. All right, what I'm going to do is come back to here. There's public travel board, so you can see what's going on, where the priorities are. There's a great book, which has a little bit, but I just got my own. Practical Node Red Programming by Taiji, who is Taiji-san, who's in Japan, one of the kind of evangelists for getting Japan going with it. Hitachi and Fujitsu are big users of Node-RED. Lots of tutorial stuff if you want to play. There's videos on YouTube as well, of course. Nick has started his own company, FlowForge, which will host things as another cloud platform, but you can also do this on IBM Cloud. We have Node-RED ready to go. It's free. Ask me about it offline. I think I've covered all the bits I wanted to show you. One thing that we can show is in kind of real life world is, so if I look at my support system that Joris and I use, this is live. We've got our content publishing. So now you'll see a little bit more about rendering. I can pull up lists on the fly. I can go and look at the code. I can dig around inside here, make it really quick and easy. So there's no need for this to be a completely repeatable program. Once I've built it to do what we need, there's only a team of maybe half a dozen people might use this. It needs to be what they need, but we can sit on the top of all the node modules that have been built that are tested by tens of thousands of users all the time, and just do our little bit of configuration for our bits of data only, with really very little code at all. One thing I found I needed was a thing called JSONata, which is a functional programming layer on top of JSON. So you can do kind of in-stream queries and data manipulation at the kind of object level, array level. Not programming, but it still has a little bit of programming feel to it if you really want to do it. I'm conscious it's 10 past, and I knew I would overrun. That's why I showed you the slides earlier on to get them out of the way. Where are we? If I move this out, the bar out of the way. Any questions that have come through? Maybe once.
There's a question from Joanna about, are there any debug tools?
Which ones?
Are there any, does Node-RED have debug tools?
So Node-RED itself has a built-in debug tool. So this one As I said, Node-RED doesn't generate code. Node-RED just generates configurations and runs code that's already there. So the code, generally speaking, the things you'll want to debug will be, what does the data look like now? It's very seldom you'll get a catastrophic failure that's an actual code failure. So when you see our, if I made this pop out the thing here, so this debug window here with a bug in it, debug messages, in the editor, that's always there when you're doing the development work. You can, as I say, you can redeploy Node-RED with a headless function, so you don't have the editor available, but you can always fire it back up again, or you can run a different version that generates the flow. So this debug will show you what the data looks like at any point. So if you want to find out, well, what did the data look like when it came back from the HTTP request? I can pop one on here. I can do my deploy. I can do an in-stream injection to say, well, I don't need to wait for the outside world to generate the event. I can create an event now that will trigger that flow to run. I can see here the data that comes back. You'll see that orange line and dot, dotted dot, or orange line rather, shows me which debug message this relates to. The payloads here, I can see all the headers that come in from the data that's come back. I can dig into any of the other properties that are being flowed with the message as it goes, and I can modify those messages as I want to. So you can turn, once you've got your debug figured out what was wrong and you fixed it, you can then turn these nodes off, so that when you redeploy, this one doesn't produce a message anymore. We just get the output. So and you can turn them back on again when you want them. They'll fire up, then you can turn it back off again. So you can leave them on. You can permanently turn them off, permanently turn them on, or do it in a transient way. Just set them. So as long as you've got a debug capability there, you can just turn it on. And the inject node gives you the ability to inject just raw events. You can inject JSON. So if you want to put some sample data together and trigger a flow, you can use JSON for it, or numbers if you want to pretend that you've got a temperature sensor, that what would happen if the temperature gets too high or too low. You can inject those into your flows. So it's the editor is the debugger, if you like. But once you're up and running, you can also in the function nodes, you can issue node.warn. So you'll find down here, you can send messages, but you can also do logging. So once you're running headless, if you like, you can then use the log events to tell you what's going on. So you don't have to stop your program. You can just log where it didn't work, or capture what your data is as you're going along, and then see whether you've got a flow problem or not. So there's lots of options too, because underneath the cover is still, it is Node.js. So it's lots of Node.js packages running. So it's got all the functionality that Node has, plus this extra layer of pretty much everything is designed to make it really difficult for you to break things by just trying stuff. It's not going to fall over. It'll probably generate an error for you in your debug log and say, no, don't do that. That's just wrong. But it won't fall over, and you have to rebuild and recompile.
That's great. Jim has a question about, can the program be exported? And if so, what file format?
Yes, you can export it, but it's not a program. So you think of it as a program entity, if you like. What you do is you can export from the menu up at the top right. You can export. Get that going, and you can choose what it is you want to export. You can export just a selection of nodes. You can export just the current flow, which is this page on the palette, that whole flow, or you can do all of them. And you can copy it to the clipboard. And then if you go to your clipboard, let's create a new file, and we'll paste it into here. You'll see it. It's not really a program. It is a bunch of blocks. Here's a block, and it will have the wires, and the wires are, where do they go to? Which of the blocks are these wires connected to or from? So you'll have, what type of block is it? You'll have some information that it needs in its configuration information, and you go from there. And the joy of this is, if I go to my Raspberry Pi, so thank you very much for this question, because it's really handy. If I go to my Raspberry Pi back here, so running on my local Weeble Raspberry Pi, I can go here and import flow, and I can paste it in, and it will pull in some configuration nodes, some of which will work. So it's probably going to bring in some Redis stuff that's not there, but oh, look, here's my program. And if I redeploy that locally, clear out the bin, I now have, grab this one again. I'm going to do this. This is now on my Pi on my desk. If I go to here and go to BCS Bed, I get the same function. So I haven't exported the program, but I have exported the definition of what the program should do, if you like. And now I can run the same program on my Pi. Obviously, if it needs things that the Pi can't see, I'm going to have to add those in, add those nodes if they're missing from the NPM package libraries, add them in, and then configure them appropriately. But yeah, this lets me transfer from an IBM mainframe running Linux to my Raspberry Pi on my laptop, well, near my laptop. Now in my house, I can do exactly the same thing I was doing. So you can do it the other way around. You can build it on your Raspberry Pi or your Mac or your Windows machine, build it, test it, make sure you understand what's going on with it, pass it across to what you might think of as your production environment, import it and run it. And if you really want, you can actually run it in Docker. So if you really wanted to just not have to worry about what were the differences when you moved it from one environment to the other, if I go to, let's go to Node-RED, which you can reach from here. We go to the Node-RED site. This knows it's a Pi, so don't worry about that. If we go to the documentation and get started, you'll see there's a Docker. And you can run this directly on pretty much every technology. Obviously, it's got all the Intel ones, but it also, from my perspective, has the cool part that it runs on an IBM mainframe as well. But there's a Docker version. You can run it, try it out without you having to do anything. Just make sure you've got the ports exposed and the data, and it will fire up, which is fantastic if you want to just test stuff, get it to work, publish that image. You create a container image, publish it, and it has everything except you can export, you can externalize the settings. So the user can have access to your container, but they still have to write the configuration that's going to be needed, and then it's imported into the container at runtime. So you have a shell container ready to go. They then do their the secret sauce to set up to talk to their database or their transaction service or their website, whatever it is they want to do. But you've packaged a Node-RED application ready to go. Any more questions? Thank you for that one. That was great because it gave me a lead to show you something.
I do have one. So while all the attraction to many people is the capability of generating complex interaction without coding, but in this community, how big is it? What does a job or career market look like for people to invest in learning Node-RED?
So we didn't think there was a huge market for it, which is one of the reasons IBM made it into an open source project. So we could use it, and you can see it wasn't used in SPSS. It's doing the same kind of things, but it's not using Node-RED. The BlueWorks tool does similar things. You could do this with Node-RED, but they chose not to. mainly because it'd been brought in from the third party. But what we've found is that consulting companies use it. IBM itself, consulting businesses, third-party consulting, retail, people who wanting to build applications that are unique to, say, a retail environment. They need to set up something for a store or a small group of stores that's unique to the way that they're running their retail information system, or retail management system. Rather than build a whole load of code to make it work, as long as there's an API and you can agree what your delivery devices are, is it an iPad or a phone or a laptop? What's the capability for that rendering? Can you do it with HTML? Then it's a piece of cake. So it's used an awful lot for those kinds of, not quite one-offs, but an MVP, progressive development model. And you probably don't hear a lot about it because once it's done, you can build something really quickly to the point where you've got like an 80–90% fit from what the user is telling you as you're putting it together. That quite often that's it. They're quite happy with it. You get a little extra bit. There's no great sale in the code, but now you've got a solution which you can build on and grow. It's been used an awful lot in sort of experimenting with event streams. So not necessarily all IoT, but a lot of historically IoT devices. But pretty much anything that throws out events and you want to catch, inspect them to see what they look like. So you can set yourself up as an endpoint for a webhook. You don't know what the data looks like for a webhook until you've received it. If you've written code for that, you spend a lot of time trying to parse your data and dumping it and using console log to work out what does it look like now. With Node-RED, you just set your endpoint up, put a debug node on, and it shows you everything. You can then progressively extend your control flows inside as you add nodes in to work out what other things you want to do. So do you want branching to do side effects from the flows, or do you want to respond with data, retrieve information? You can do all that really fast. So it's not necessarily, you won't see it in job ads for people saying, oh, we really want someone who's a Node-RED developer. But if you've got someone who's a Node programmer, JavaScript programmer, full stack developer who can use Node-RED as a tool for understanding how the data is going to work, how the flows will work, you can patch it all together with Node-RED. And in a lot of cases, that's actually what is needed, and you can stop there. Or you can then take that model that you've built essentially with the flow-based programming approach and say, now what would that look like if we did it with Java or Node.js or Python? And it's worth mentioning that this is a Node.js packaged environment. So the code that it can run, by and large, is Node.js. There are some capabilities for you to add on Python support, but essentially what it uses is shell. So it will shell out to a Python module, and you can do stuff with Python, and then it comes back again. So it's designed to be Node.js based rather than a general any old programming language you like kind of tool. Does that answer your question?
Yeah, I think so. My understanding is that it is perhaps a good additional skill for people on already doing Java type work.
So what I've worked with people who are not programmers, but who have used it. One of the first people I met who introduced it, Node-RED, to them, went off and created himself a web application that monitored a number of different websites, screen scraped them, because you can use there's an HTML node which does CSS queries. So you can do a CSS select on scraped web pages. He collected the data from a number of different websites and essentially set himself up with an autonomous agent to say, when the price of disk drives, graphics cards, heat sinks and CPUs are in the right price for me, and then buy, or at least tell me about them and I can go and buy them. So he would monitor various sites. He didn't have any programming skills at all. All he needed to do was a little bit of CSS to find the objects on the page, which you just get by doing, a visual inspection of the source. Find the bit you want. It's a little bit more complicated when you've got dynamic pages going on, but when you've got relatively static content, you can scrape the pages, generate yourself a really simple, if it's this, then do that. If it's within this range, send me a text message. One of the things I'm working on for our hackathon is to generate text messages with the Twilio service, where you can get free account and send text messages pretty much anywhere in the world. From Node-RED, there's a Twilio node, costs you nothing. You can send text messages. So he does that, and he had no programming skill really. So you don't have to be a coder to be able to use it usefully. If you are, then it's really useful, because I've programmed in assembler through PL1, COBOL, Java, Rex, Python, languages that are long dead, Fortran, it's not dead, but those kinds of things. And I use this tool pretty much as if I know I'm just going to create something quick and easy, it's fantastic. And if I don't know what I'm going to create, I can use it to experiment with what the data looks like and what the ultimate solution really might be. Particularly if it's an environment where you can't really run Node-RED for memory requirements, those kind of things.
Great stuff. And thank you, Joris, for putting down the link for people who want to try Node-RED using IBM Cloud.
Thank you, Joris. Yeah, so Joris is with IBM. I wasn't going to give the plug, but he can do it because he's joined the call for you. Yeah, it's free, and you can run it in the cloud free. You can run it in pretty much any system where you can run Node.js. So you can run it on Azure, you can run it on AWS, you can run it on Google Cloud, run it on your Windows machine, a Mac machine, Raspberry Pi, Linux desktop if you've got it, Linux mainframe if you have one. If you don't have one, ask me and we can get you hooked up with one. So all of these things for free, cost you nothing. And if you find that the thing you really want to do, and you want to do like powerfully, and it's just not there, there's nobody written the code for it, you can't find the library, create one, publish it, and then you save work of generations to come that won't have to write more code.
Brilliant. Just wanting to check, are there any further questions from anybody?
Yeah. I'll encapsulate the links of the things that I've pointed to, Paul Morrison's paper. Lots of these things you can find from Wikipedia, but I'll put them all in as links. So that is there support for LoRaWAN? Yes and no. You need to have the device to do LoRaWAN. There were a company called Multitech had a LoRaWAN gateway. I have one in a box. I don't have it sitting here anymore because it was getting in the way. But I have one that it's got a LoRaWAN transceiver on it, and they offload because it's you need to have licensed code to talk to those kind of low power WAN. So LoRa, you don't need the code, but you need to license the device. Sigfox, you have to have license use to be able to get to the libraries. So there's usually a binary somewhere, but there's a Node-RED wrapper which sits around it and brings the data in and out of Node-RED itself. So if you wanted to create a LoRaWAN application, go and have a look at things like the Things Network. they've got all those devices all firing up. You can then pull the data in, create yourself an MQTT bridge application, and go from there. So yeah, I have a gateway on the house, which is Sigfox gateway, but I also have this LoRaWAN device to do the same kind of things. So yes, but you have to look at where the code has to be to make it work.
Okay. Well, yeah. So George, it seems to be a little bit more work on that. So, okay. Right. So I'm sensing that it is 8:30. So thank you very much, Ross. And well, for those who are here, we can give him a physical round of applause. And hopefully, when we come face to face, we can do a little bit more. What I'd like to do is to very quickly wrap up, and in the wrapping up, really to do one thing is that for folks who are who are not members of the BCS and find joining the community of interesting, then there is a discount code for membership if you join in from the BCS Bedford connection. So I put on screen the discount code here. So anybody who want to join in the BCS as a member, and you can use this as something that gives you, I think it's a 20% discount, or if you want to follow it up later, you can approach me. When we were meeting face to face, we have this little sticker that we give people. Nowadays, of course, I can't put a sticker on the wall, but you can use this code. And with that, thank you, Ross, again, and thank you, everybody, for the evening. We hope we'll be able to see you in our next meeting. And the link to the recording and the PDF shall be up on our website, hopefully in the next couple of weeks' time.
Right.
So thank you for joining, and enjoy the rest of the evening. And we'll look forward to see you again in some future event. And thank you, Ross, again.